In this video, we're going to look at how to check circulation. This is chapter 21, part 8. So the alternating expansion and recoiling of elastic arteries after each systole of the left ventricle, this creates this traveling pressure wave that's called a pulse. Now the pulse is strongest in the arteries that are closest to the heart, and it becomes weaker in the arterioles, and then in the capillaries this pulse disappears altogether. Now a pulse might be felt in any artery that lies close to the surface of the body that can be compressed against a bone or another firm structure. So this table here shows some of the common pulse points. One of the most common is the brachial artery, right here, kind of close to the biceps brachii muscle near the antecubital region. The radial artery is also very common down here on the lateral aspect of the wrist. Also along the neck here, and the common carotid artery is going to be another very common place to find a pulse. And there are a couple places on the leg as well, including the femoral artery and the popliteal artery, and even on the dorsal artery of the foot. So definitely a couple places where you can find a good pulse. Now when testing blood pressure on a person, as we know, we use a blood pressure cuff, also called a sphygmomanometer. So sphygmomanometer. And this is where you inflate that cuff on their arm, and when the cuff is inflated fully, you're going to have a pressure kind of up here somewhere. And then we're going to slowly deflate that cuff. So that's going to be this blue line here, that pressure in the cuff there. Now this red line, this red line here, this is representing the heartbeat. So you can kind of think of these bumps in the red line as passing through time, because time is going to the right here. So think of them as going forward as we're bringing down the pressure in the cuff. So we're going to have one bump here and then here, and kind of all throughout time it's continually moving. So when the cuff is deflated enough to allow that crushed artery to open, because when it's fully inflated, we're cutting off some of that circulation, we're crushing some arteries just for a time, and we deflate it a little bit enough to allow that crushed artery to open, and we have a spurt of blood pass through. Now the result is the first sound that's heard through the stethoscope, and this first sound that we hear through the stethoscope corresponds with the systolic blood pressure. And remember, the systolic blood pressure is the force of blood pressure on the arterial walls just after ventricular contraction. Now as we continue to deflate the cuff and continue to deflate, suddenly these sounds become too faint to be heard through the stethoscope. Now at this level, it's called the diastolic blood pressure. And remember, this diastolic blood pressure represents the force exerted by the blood remaining in the arteries during ventricular relaxation. At pressures below the diastolic blood pressure, you're not going to hear any sounds at all. Now, these various sounds that you're hearing while taking the blood pressure, these are called Korotkoff sounds. So those heartbeats that you hear while taking blood pressure through your stethoscope, called Korotkoff sounds. Now this difference between systolic and diastolic blood pressure is called the pulse pressure. So here going to be the systolic pressure, down here the diastolic pressure. So we're looking at about 120, maybe 70 over here. So our pulse pressure is going to be our systolic blood pressure minus our diastolic blood pressure. In this case is going to be 120 minus 70. So we're looking at 50 millimeters of mercury as our pulse pressure in this specific example. And that's going to be the end of part 8 for chapter 21.